Hi again. So in this video, I want to show you how to find a theoretical p-value with Stapplet, and then I'll show you GeoGebra as well. So let's go back to technology here. This is my stat key. I've also got my Stapplet open, and you should have a link directly to the chi-square distribution, but in case you're just at stapplet.com and you want to find it, we've got normal, t, we'll use t after this one, and then chi-square. Okay, and it has the same options, area or value. So we're going to be finding an area, which is a p-value, and we put in our degrees of freedom. So remember we calculated that was 2, rows minus 1 times columns minus 1, and we get this distribution. So it has a similar shape that we saw in the simulation, right? 0, it starts out really high at 0, and then it goes down. But if the degrees of freedom are higher, it looks a little different. We are calculating area to the right because it's a right tail test, and then here we can put in our test statistic of 106.351 and calculate area. And I like to show the labels on the plot, and so we can see at 0 this is coming down to the x-axis around 12, and our value was 106, so definitely a area of 0. And so in this case, the simulated and theoretical came out identically because it's so far off, right? So such a big difference. But if you were in the 6.4 to 6 to 8 range or less of with the chi-square test statistic, then your simulated and your theoretical might be a little different, right? So just keep in mind whether a question is asking for a simulated p-value or a theoretical p-value, okay? So theoretical is going to be more exact from this chi-square calculator because the simulated can vary more, okay? Okay, so let's go back to the notes, and I have a screenshot of that just so you can remember what to do. So we're calculating an area, degrees of freedom 2. This is always a right tail test, and we put in our chi-squared test statistic, and then this is our p-value. That's our area. Okay, great. Okay, just like you're used to doing. Now let's go into GeoGebra. Let me show you that one. And then you can decide if you prefer GeoGebra or StatKey. So remember, I'm in the GeoGebra.org classic probability. You might come up with this one distribution, but we want the statistics tab. And very down at the bottom, we have goodness of fit and chi-squared. So they don't mention independence, but we want, for independence or homogeneity, we want the one that's not goodness of fit, and you'll know the difference. So I just want to show you both. This has a rows and columns, right? Versus if you get into the goodness of fit, it just has one row. Well, they're doing a column, one column, and then there's a place for the expected that we have to calculate, right? So you'll see a two-way, I call it a two-way table. And you can set the rows and columns. So I want it to go the other way. I want to have 2 rows and 3 columns. Now I do have to enter my original data, my observed, but it's going to calculate the expected for us. So that is kind of nice. So whether it's StatKey or GeoGebra, we do have to enter those either way. So if you have a preference, you can decide. Let me get my table here so I can and type this in. So I'm gonna just go ahead and label everything. I'm just gonna abbreviate a little bit though. Obama, Democrats, and Republicans. And then I'm gonna go approve. You can use the tab to go between, which is nice. 842, 736. 541. Tab goes down to the next row too, which is great. Disapprove. 616. Tab 646. Tab 842. Okay, and again, we're not doing the totals. It is calculating. You can see it calculated the column totals for us. So we can use that as a nice double check. So we're coming out the same. Okay, great. And already we can see it's calculated the degrees of freedom for us, the chi-square test statistic, and the p-value. Okay. Now you can click expected, and so that's like what we saw in StatKey. The next one down is what we would expect. So you can, it's kind of interesting to see which ones are larger, which ones are smaller. And you can also do the chi-squared contribution. It's not color-coded like StatKey was, if that's important to you. I'm also curious, I can't remember what this column percent, row percent does. I don't know if that's super useful at the moment, so, but I think that's doing that proportion that I was talking about before. Okay, great. So you can also use this, just depends which one you prefer for entering the data, really. I think GeoGebra or StatKey, they both will give you the chi-squared value. This one, remember, this p-value is the theoretical one, so that's good to know, versus on StatKey, this is the simulated. And remember, not much difference here, but there could be, depending on the situation. Okay, so let me go back to the notes. I got a screenshot of that for you, so you can remember or refer to it when you go to this. So statistics tab, chi-square test, we got to put in our number of rows and columns, which you'll want to make sure this matches anyway. And it does calculate this for us, which is really nice. So it didn't for the goodness of fit. We had to do that ourselves, but it does for this one. GeoGebra does calculate the expected counts, okay, which is really nice. And then, of course, we have our test statistic and our p-value. Okay. Okay, great. So I want to show you those two technology pieces, and then we'll go through the more formal steps and conditions for these tests in the next video. So see you there.